Hi, it's Matthew Reed here, and today we're going to be making the second in a series of videos about the treatment of this electromagnetic hip toggle clock. We're going to be looking specifically at the treatment of the electromagnetic coils that drive the pendulum. So we start here with the coils, and you can see from this image some of the windings have come undone, and the insulation, which is possibly silk, has some losses. So we've got to be careful how we proceed with the treatment. What we're aiming for here is to remove the coils, give them some cleaning, and then test them for electrical soundness and reinstate them. And that's about it. I don't really want to do anything else. You can also see here that the gap between the two pole pieces of the coils is not even in relation to the bar at the bottom of the pendulum. What this will mean is when the pendulum gets its impulse, pendulum will wobble. So we want to try and correct that. So to remove the coils, you can see here that the terminal blocks are quite corroded. So we've got to go carefully at this. I don't necessarily want to refinish these blocks, but I do want to try and get them off without breaking too much. The reason they're so corroded is probably because of acetic acid that's evolved from the oak backboard, and that I think is probably okay nowadays. Nevertheless, we want to make good electrical contact. So what I've done is I've applied a little bit of penetrating oil, and we're just going to make sure the screwdriver is a good fit in the slot by giving a bit of a tap with a brass hammer, and then we'll tentatively see how these screws come undone. And there we are. As I suspected, you can see here this sort of copper based corrosion product on the thread of the screw, which we'll remove some of when we come to the cleaning process. And obviously underneath the screw head, there'll need to be some cleaning there to make a good electrical contact. So we'll just deal with the other side in exactly the same way. So to remove the coils from the bracket, I'm going to use an adjustable spanner. It's a square nut. You can see here that the bracket is actually loose on the backboard, so we'll need to attend to that at a later date. So there we are, the coils are removed from the bracket, and I've replaced the nut. So the first thing I'm going to do is to put these terminal screws safely, so I know which goes on which side. They're probably interchangeable, I think they're BA screws, but this is kind of good practice to take a piece of card, or paper in this case, and make a little cross with a scalpel into which the screws fit. The next thing I'm going to do is to secure the windings with archival cotton tape, so that situation doesn't get worse as we work on the coils. Now I'm going to test the coils in their present arrangement, and you can see of course that where the joining wires are, that there's likely to be an unsatisfactory situation there in terms of resistance, but we'll try anyway. You can see here that one coil has got two pieces of paper between the bobbin and the metal armature, and the other one has got none. I suspect they're meant to have one each. So we'll just gently lift those off. I reckon that is where it's meant to go. I need to clean up the ends of the wires. I'm just going to use a little bit of steel wool in order to get a good contact. So now we come to test the coils for resistance and see if in fact they work at all, and with the correct setting we see that together they are reading about 18 ohms, which is what we might expect. However, I can see that this connection between the two is going to be troublesome, and in fact if we wiggle it a bit we can see that the resistance is all over the place. So that's unsatisfactory and we need to deal with it. Tested individually, one coil reads 9 ohms, which is what you'd expect, half of 18, and the other one reads about the same, 8.9 ohms. So that's great. Happy there that both coils are in reasonable condition, despite the fact that the insulation looks a bit rough. So now to disassemble this part of the armature using our vice protectors, we'll get a big screwdriver and take the thing apart for washing. We can see underneath that there's a little bit of light rusting, corrosion, but nothing at all significant. So I'm cleaning in a white plastic tray. I'm using natural bristle brushes and I'm washing in low odour white spirits, just regular DIY shop type low odour white spirits. We're of course using personal protective equipment, good ventilation or extraction as appropriate. You can get the manufacturer's safety data sheet for these solvents online. Where there's a little bit of light rusting, you can see me using 4/0 steel wool held in a pair of brass tweezers just to remove that kind of three-dimensional corrosion product. And then I'm rinsing now at least once, maybe twice, with fresh white spirits. When I'm happy that the components are washed, I leave them to dry in a tray lined with acid-free tissue paper. So I've reassembled the 5 components, and to prevent further rusting I'm going to just apply a layer of microcrystalline wax with a natural bristle brush. So I'll brush it on, leave it to dry, and then remove any excess. Put the screw back to remember where it went. And now to clean the ends of the bobbins, I'm using a homemade cotton swab, again with a bit of microcrystalline wax, which is white spirit based, to remove some of the dirt. You could use a little bit of distilled water. Don't, in this instance where there's shellac lacquer involved, use anything that's methylated spirits or similar base, because it'll dissolve the lacquer. So we'll just continue there. Again, I don't need the surface to be shiny clean, I just want to remove some surface dust. Next I use a length of archival cotton tape to clean out the bores of the bobbins just by drawing it back and forth. It's actually really useful material for cleaning clocks, for cleaning out larger bearing holes and such. So just gently clean away some of the dust and dirt. So now the bobbins are cleaned, I just want to make a little connector for the wires. So I'm going to take a piece of Tufnol, phenolic plastic, and make a little block with a brass BA screw just to hold those wires together. I don't want to solder them or anything. So I'm reassembling with a piece of paper in addition to original pieces of brown paper, and there we are. So we can now test the assembly. I'll put the armature near, and using a 1.5 volt battery as our little test current, we can see if it works. Yay! So there we are. It works. Happy there. So I'll set these aside for the time being. So we'll just turn our attention to the coil bracket. You can see it's loose. I'm going to remove the screws, and again I'll expect them to be tight. They're brass screws, so we have to be careful with those screw heads. And they're corroded, as you might expect. I'm happy with how that looks. It's obviously not very flat on the back, so I'm going to vacuum the case and then wash the bracket in the same way that we did the metal parts of the armature. And when we look at the back of the bracket with a steel rule, we can see that the rule rocks, so it's not satisfactory. So what I'm going to do, I could obviously file it flat, but I want to preserve the back, so I'm just going to use a couple of slips of paper, and indeed you can see that that makes the whole situation much better. So refit the bracket, pop a couple of pieces of paper behind, screw down the screws, and then with a scalpel, I'm just scoring the paper here. Obviously I don't want to cut into the wooden backboard. Remove the excess, and the same at the bottom, and the bracket is firm. So that's job is done. So I hope that was useful. We haven't quite finished with the treatment of the coils, but I'll save the rest of that until we come to reassembling the clock. So next time we're going to be turning our attention to the electromagnetic switch, which is part of the hip toggle mechanism, and I hope you can join us then. And again, thanks for watching.